Hi, this is Ella. I'm pleased to present our work on knowledge distillation beyond model compression. This is a joint work with Fahad Sarfraz and Bahram Sunus. KD is an effective model compression technique which trains a complex model under the supervision of a larger pre-trained model or an ensemble of the methods in an interactive manner, which is more similar to how humans learn, and it consistently improves the generalization of the compact model. The goal of our study is manifold: to provide extensive analysis of how the underlying mechanisms of different KD methods affect the generalization performance of the students and find general patterns and characteristics of the models to aid the design of efficient distillation methods. Additionally, to showcase the efficacy of the KD framework as a robust general-purpose learning paradigm and analyze its characteristics. While KD has proven to be an effective technique, a clear understanding of where knowledge resides in a deep neural network and how to effectively capture and transfer it to students remains an open question. Consequently, there is still a considerable performance gaps between the students and teacher. To this, and a number of methods have been proposed which differ from each other with respect to how knowledge is defined and transferred from the teachers. To highlight the subtle differences, we present a broad categorization of these methods. Response distillation aims to mimic the output of the teacher's methods, includes the original KD formulation by Hinton and BSS, which matches the decision boundary using an additional boundary supporting loss. Representation space distillation, on the other hand, aims to mimic the latent feature space of the teacher's method, include FitNet, FSP, and finally it uses attention as mechanisms of transferring knowledge. Relational knowledge distillation aims to mimic the structural relations between the learned representations. RKD trains the students to form the same relational structures with that of the teachers, whereas the SP encourages the student to preserve the pairwise similarity in the teacher. Online knowledge distillation aims to circumvent the need for a static teacher and updates both the student and teacher simultaneously. DML involves knowledge sharing between a cohort of compact models trained collaboratively, whereas one uses a single multi-branch network and uses an ensemble of the branches as a stronger teacher. KD aims to minimize the generalization gap between the teacher and the students. Therefore, the generalization gain over the baseline is a key metric for evaluating the effectiveness of a KD method. We compare the distillation approaches on different datasets, including C410 and C400, and network architectures with varying capacity gaps between students and teacher, and show that KD is an effective approach. For detailed analysis on the results, please refer to the paper. The key finding: KD is effective and versatile enough to cater to different datasets and network architectures, even for the higher capacity gap between the students and teachers. The methods which provides more flexibility to students in learning are more versatile and can provide higher performance gains. The performance of relational knowledge distillation method shows the effectiveness of using relation of the learned representation. Furthermore, the promising results of online distillation highlights the effectiveness of collaboration. To demonstrate KD as a general-purpose learning framework, we now show its effectiveness against common challenges. Learning efficiently under label noise is a major challenge, and one reason for the failure of a standard training is that the only supervision the model receives is the one-hot labels. KD, on the other hand, can provide additional supervision about the relative probabilities amongst the classes or consensus between different students. We hypothesize that these extra supervision signals in the KD framework can mitigate the adverse effect of incorrect ground truth labels. To test our hypothesis, we simulate uniform label corruption on C410. We showed that majority of the KD methods improve the generalization of the students trained under varying degrees of the label corruption over the baseline. Another common challenge is high class imbalance, which is naturally inherent in many real-world application models trained with a standard training exhibit bias towards the prevalent classes at the expense of the minority classes. Since the model received no information about a particular class other than and the data points belonging to it. No information about the similarities between data points of different classes is available. We hypothesize that additional relational information in KD can be useful in learning the minority classes better. To test our hypothesis, we simulate varying degrees of the class imbalance on the CFR10 dataset and show that the majority of the KD methods provide generalization gaps. Our key takeaway message is that efficacy of the KD goes much beyond a model compression technique, and it should be considered as a general purpose training paradigm which offers more robust to common challenges in the real world dataset compared to the standard training procedures. Thank you for your attention.